Hello everyone. In this video, let us discuss about biasing by fixing VGS in MOS amplifier circuit. So, why do we need? Firstly, why do we need biasing? So, we need a good biasing such that to establish an appropriate DC operating point for the transistor. So, how do we get a appropriate DC operating point? So, by having a stable and predictable DC drain current ID and the voltage VDS. As we know, so in our MOSFET, our output current is ID and our output voltage is VDS. So also, our MOSFET should operate in the saturation region for all expected input signal. So these are the requirements for our biasing techniques. So in that, let us first discuss whether biasing by fixing VGS is good or not. Can we achieve all these requirement by biasing by fixing VGS? So let us see the circuit. So this is our MOSFET. So this is drain terminal. Let us connect the resistance RD and this is by voltage dividing RG1 and RG2, and this is our gate, this is our drain, and this is our source. Let us connect this to VDD, and this is also grounded. So here, since there is no resistance across the source, the gate voltage is equal to the voltage between the gate and the source. So by the voltage divider rule, so the voltage at VG, the voltage at the VG is VDD into VDD times RG1 into RG2 divided by RG1 plus RG2. This is the voltage across gate, which is also equal to VGS. Okay. So also we have the current ID in the saturation region. The current ID in the saturation is given by, so ID is equal to half mu n COX W divided by L times VGS minus VT the whole square. So COX is the oxide capacitance, omega L is the transistor aspect ratio. So even if we have a MOSFET of the same size and type, so these parameters will vary from device to device, that is from one device to another device. Now if we make VGS constant, that is we are fixing our VGS such that it will not vary. So if we fix our VGS, so that VT and all these parameters will become more temperature dependent, since we cannot vary in this parameter. All these parameters will become more temperature dependent. So if this become more temperature dependent, our ID will vary. So the current ID will vary if we change, if we fix our VGS. Since our ID current is dependent on all these parameters, and as you know in the previous video we have discussed, our ID is more dependent on VGS. That is, by varying VGS we can control our ID. Since we have fixed our VGS now and all these parameters has been dependent on temperature, our ID, we can't have a stable ID. So the biasing by fixing VGS is not a proper biasing technique. Also we can say, for a proper biasing techniques, our delta ID, So if we put a graph on VGS versus ID for the different device of the same size and type, so we are fixing our VGS. Okay, so VGS is fixed. Now we are not going to change our VGS. And if you put a graph of VGS versus ID, so if the graph looks like this. This is the ID current for device 1. So this is device 1 and also this is device 2. This is ID 1 and this is ID 2 and this is delta ID. So we have discussed the delta ID divided by ID should be small, then we can say our circuit is stable. Okay, but here delta ID divided by ID is large. So our circuit, that is biasing by fixing VGS, is not a proper biasing technique. Okay, so that's why we can say biasing by fixing VGS is not a proper technique. So in next video we'll see the biasing by fixing VG, that is only the gate voltage. So whether it is good or not. Okay, thank you.